We want to invite teams from Nairobi, from Kisumu, Mombasa, and Karachi, and also friends of Aga Khan, friends of BMI who are joining today in this session. My name is Catherine Bikeri. I'm a project manager at the Brain and Mind Institute and also a clinical psychologist, and I'll be your moderator for today. You may have asked yourself, why do some people age better than others? How come some people bounce back from adversities better than others? So the Brain Resilience Kenya study sought to explore the biopsychosocial factors that influence risk and resilience in brain aging. And we'd like to answer some of those questions today, and we will be led by our panelists, our presenters. So our first presenter is Dr. Karen Blackmon, who is a consultant neuropsychologist here at the Brain and Mind Institute. She has extensive training in clinical psychology and neuropsychology from institutions in New York. Her work majorly focuses on expanding culturally appropriate neuropsychological and assessments and interventions in regions heavily affected by neurological disorders. She has received major funding. She has authored up to 50 peer-reviewed articles. She has contributed to global research collaborations on conditions such as epilepsy, Zika virus, and COVID-19. In addition to research and editorial roles, Karen is involved in international neuropsychology organizations with a broader goal of improving prevention, management, and reducing global disparities in neurological health. Beyond her accolades, Dr. Blackmon is a dedicated researcher, leader, someone you have pleasure working with. And I am very privileged to be working with her, under her in this study. Our second presenter will be Dr. Bernard Alaka. Dr. Bernard Alaka is a postdoctoral research fellow at the Brain and Mind Institute, where he applies advanced artificial intelligence techniques such as computer vision to develop innovative brain imaging solutions by integrating MRI, fMRI, and wearable data for improved clinical insights in neuroscience. He holds a PhD in computer science from Strathmore University, with expertise in areas such as natural language processing, speed technology, and data engineering. He also has experience as a lecturer, consultant, researcher, with over 10 peer-reviewed publications and roles as a journal reviewer and mentor through initiatives like Young Scientists of Kenya. He actively contributes to advanced research and nurturing future innovators. As a colleague, Dr. Laka is soft-spoken, but he's a force when he sits to analyze data and to do computations. He's a force, and it is a blessing to have him in the team, and we look forward to hearing from him. So I want to, as we think about the future, we are talking about what does it mean to age better? What does it mean to be resilient? How to bounce back? But remember, we are here today. We are here now. And I want to welcome all of you to just take a deep breath and acknowledge your presence here. If you haven't remembered to breathe in, take a moment and take a deep breath. Deep in through your nose. Out through your mouth. Okay. Drop your shoulders. Let your shoulders drop. Relax. Okay. All right. Thank you very much, and you're welcome. So this session is being recorded, and by acknowledging that, we know that you're all comfortable with having this session recorded. There will be room to ask questions at the tail end of the presentations. If you're afraid of forgetting your questions, you may put them in the chat, but there will be an opportunity to raise up your hand and ask your questions at the end. So to start us off, Dr. Blackmon, karibu sana.
Thank you, Catherine, for that introduction. Thank you all for the chance and the privilege to share our most updated data with you from the Brain Resilience Kenya study. I'm grateful for the team's confidence that I am able to share, that Dr. Alaka and I can share the data with you. This is a team effort, so it's a privilege to have everyone's trust to share some of these first findings. I met, 2 years ago, I gave a talk at the FAR rounds, and we shared some of the data then, but it was so preliminary. We had just started. So it's very exciting to see how far we've come. To remind people the rationale for this study, we know that brain disorders are the #1 contributor to disability burden globally. For the clinicians in the room, this is what we care most about. Although we can't cure every disease, we can try to reduce the impact on people's lives, and we can reduce disability. So our goal is to not simply cure diseases, but manage those diseases well. I see Dr. Mansour Saleh is here, who is our partner in the oncology unit, who has worked closely with us to, through this study, reduce the burden of cancer on people's lives so that he can not only cure the disease, but also reduce any disability associated with it. So over here in the first panel, you'll see that most disability burden accumulates with age. On the y-axis, as age increases, we see a growing disability burden from neurologic disorders, mostly driven by stroke and as well as Alzheimer's disease and other dementias. Many of these diseases of aging are preventable. The Lancet Commission has published a set of factors, 14 factors that, if addressed, could reduce the burden of dementia by up to 45%. We've published from the Brain and Mind Institute a broadening of those risk factors to include factors like poverty and HIV, which, if addressed, could reduce the burden up to 65%. We know that as populations age and grow across the global south, that the burden of dementias will rise. So we are actively working to better understand the factors that drive the rise in dementia burden across the global south, in this case specifically Kenya. Our research strategy at the Brain and Mind Institute is to understand dementia so that we can better detect it and prevent it. So the Brain Resilience Kenya study is part of that overarching effort. Since 2023, we've been enrolling participants in the study ages 35 to above. And when people enter the study, we're assessing a range of factors, both risk and resilience factors, or risk and protective factors. By protective factors, I mean things like social connections, education, sufficient nutrition, a sense of security and safety. And by risk factors, things like vascular risk factors, cancer, HIV, multidimensional poverty, and stress. All of these risk and resiliency factors can accumulate to have impact on our bodies and our brains. So what we want to understand is which factors are the most important levers to address to reduce the burden on brain aging so that we can promote healthy aging and reduce frailty or pathologic aging. Today, we'll focus mostly on the brain aging metrics such as MRI and cognitive functions. In a future talk, my colleague, Dr. Chinedu Udemomo, will focus more on the biomarkers. Overall, we believe that the biomarkers are another way of looking at the same thing, that essentially these risk and resiliency factors impact our bodies and our brains. But when the brain ages faster than the rest of the body, we call that dementia. Again, thinking about that, coming back to that point, it's important. We know that all of our organs age. Dementia is when the brain ages faster than the other organs. And most of us fear this. It's not one of the most feared diseases of aging, that we won't be able to maintain our brain health, feel like ourselves, be able to think the way we as scholars like to use our brains. So protecting against brain aging is a major goal. It's not just enough to have risk factors. We know that there are several resiliency factors that mediate that risk or mitigate that risk. So there, of course, everyone faces a range of stressors in life, but depending on their degree of resiliency to those stressors, that serves as a buffer between the stress and ultimately the impact on our brain. So our goal is to understand what are some of the biological, psychological, social, and cultural factors that can bolster that resiliency to allow people to age well, even in the context of stressors. In our study, we've enrolled 208 healthy controls, 42 people with newly diagnosed breast or prostate cancer, as well as their caregivers. The reason for this study design is we're interested in understanding, with increasing degrees of stress, does that impact brain aging? So we enroll participants and follow them over the course of a year. If you think about stress exposures, our healthy controls are exposed to the normal everyday stressors of life. People with cancer, of course, have a much higher degree of stress because of this new diagnosis. They have the biological stress on their body as well as the psychological stress of this new diagnosis and what it means. And their caregivers share that psychological stress, but don't necessarily have the biological stress. So with those varying degrees of stress conditions, we're interested in looking at the impact on a range of factors over the course of a year. So we followed participants in our study for 12 months. And at the end of 12 months, which we're now approaching the end of our study, we assess all of the same cognitive and neuroimaging factors again, and as well as depression, anxiety, and scales and questionnaires, which I'll talk more about. Every week, participants in our study are given a task on their phone. They're filling out a questionnaire about their overall vitality, their strength, their mood, their sleep. And that helps us understand the week by week fluctuations, especially in the context of cancer treatment, where people are undergoing surgery, chemotherapy, and that can have an impact on their overall vitality, as well as brain fog and brain health. So every week they do a phone game, and we are recording their steps and their sleep and their heart rate variability with a Fitbit. So Alaka will tell you more about that data. What I'll talk to you about is some of the findings on cognitive aging from the baseline. So when they start our study, we do a range of different cognitive tests and questionnaires. And today I'll share that data with you from 246 people who are enrolled in our study. The mean age is 51. The range again is 35 to 81. Roughly half or 57% female. The participants that I'm sharing with you today in this analysis are cognitively unimpaired. And we know that from a cognitive screener that we do at the beginning of the study. And I'm looking at a range of factors to predict who falls into three different categories. Those outcomes are categorized as resilient cognitive aging, typical cognitive aging, and at risk. And I'll tell you more about that, how we define that in a minute. So the outcome is cognitive aging, and the analytic approach is to enter all the risk and resiliency factors at baseline into a sequential lasso regression, where it's a life course framework, and I'll explain that as well. It involves 19 predictors across 5 blocks with 10-fold cross-validation and bootstrap resampling so we can get confidence intervals for the odds ratios. So the 12 cognitive tests involve wordless learning, recall, and recognition to test verbal memory, story learning and story recall for narrative memory, visual associative learning for visual memory, animal naming, which is generative verbal fluency, digit span forward and backward, which is a measure of working memory, and a match test, which is a processing speed visual matching task, a flanker attention task, and set shifting, which is being able to shift between different tasks at the same time. So most of these are done on a tablet, but some are done with paper and pencil. In the end, we take these 12 cognitive tests, the scores from each of them, create a composite, and then residualize that for age, so control for age, the linear and nonlinear effects of age, and education. And we get a resulting distribution that shows each person's cognitive composite adjusted for their age and education. So in green, we have people who are resilient cognitive agers. What that means is that at any age and for any level of education, they are performing above their peers. So they have a lot of room, let's say, to sustain any stressors and have little impact on their cognitive functioning. So that's what we call resilient or reserve, cognitive reserve. In the middle, we have 166 typical cognitive agers, and then we have 38 at risk. So these are people who are performing below their age and education matched peers. However, they're not cognitively impaired. They're at risk. So you'll notice just one thing that's important to point out, even though this is education adjusted, meaning these are people who are compared to their education matched peers, the big circles are those who have secondary school or above, and the tiny circles are those who have primary school only. There are no people with tiny circles in the resilient cognitive aging. So even though we did the adjustment, that makes the important point that nobody that had either no formal education or primary school only made it into the resilient cognitive aging group. And we'll come back to that because that's an important point, that to have the wherewithal to withstand stressors and brain aging, sufficient early education is a major protective factor. So what are the other factors we looked at? In this life course predictive modeling approach, demographic and early life factors, such as whether someone experienced childhood hunger, whether they grew up in an urban or rural setting, whether they experienced multidimensional poverty. After controlling for those early life and demographic factors, we looked at the presence of stressor, like a new cancer diagnosis or life events over the past year. We looked at subjective stress, their sense of self-perceived stress and loneliness, protective factors like their sense of safety, whether they have a partner, their sense of resiliency and flourishing, and health and lifestyle factors like physical activity, sleep, their vascular risk score, and smoking or alcohol use. So you'll notice that these are more distal factors versus proximal factors in terms of childhood versus midlife risk and resiliency factors. Multidimensional poverty is an important factor that includes things like food insecurity, water insecurity, living standards, and barriers to health care. Objective stressors in the healthy controls include things like recently moving, having a financial shock, loss of a relationship or a job, medical disease, pregnancies, miscarriages, or legal problems. So these are just common everyday stressors that someone may face in life that can take its toll on the brain and body. Regarding protective factors, we developed a new scale, and this is something that we're proud of at Brain and Mind Institute, because rather than asking about a range of adverse early childhood experiences, we focus on what we want, which is safety. So we ask people things like, in your childhood, how safe did you feel at home? How safe did you feel at school and in your neighborhood? And the same thing for adulthood. For those with low literacy or low education, we added a color bar with the numeric scale that insinuates safety with the colors green and blue and threat or unsafety with red. And that's a universal color scheme that is fairly ubiquitous across the world. So that lifetime sense of safety scale is now been accepted for publication in Nature Communications Medicine. So that will be coming out soon. And it gives us a numeric rating of someone's sense of safety throughout their lifespan. We also look at health and lifestyle factors like the CADE score, which includes someone's blood pressure, their body mass index, their total cholesterol, and physical activity. So a range of lifestyle and biological or vascular risk factors. So when we predict resilient cognitive aging, or those who fall into the green group, we are able to predict with a high discriminative accuracy of, you can see here, 0.89. So our overall model was strong in predictive modeling of resilient cognitive aging. And the largest block that predicted who falls into the resilient cognitive aging group was early life factors. Things like poverty and childhood hunger were strong predictors of late life brain aging. After accounting for those early life factors, lifetime sense of safety added protective value, as well as reduced sense of loneliness and reduced sense of stress. So thinking about that again, even in the context of risk factors like early childhood hunger or poverty, a sense of safety and social connection served as protective factors with brain aging. Importantly, none of the participants with low education or no education were, again, in the resilient cognitive aging group. Nobody who were classified as multidimensionally poor were in the resilient cognitive group, and none of the participants with HIV were in the resilient cognitive aging group. So that, although cross-sectional, argues strongly that these are necessary preconditions for cognitive resiliency in later life. So they're important levers that we should target in any interventions to improve healthy brain aging. This is a summary of what I just said. When it comes to predicting the other end of the outcomes at risk aging, again, demographic and early life factors matter the most, but we do see important predictive value from the CADE risk score, which is very much aligned with what's been found in the US and in Europe, that the CADE midlife risk factors are important for predicting or reducing risk. Protective factors were included flourishing and high sleep and growing up in an urban environment, which probably is due to having access to health care and education or more resources in urban environments. It's worth pointing out that the overall model accuracy was a little bit lower in predicting risk. So we do a better job at predicting cognitive resiliency. And the way I think about that is we do a better job bolstering cognitive resiliency by providing people with sufficient conditions for successful aging later in life. So if we're going to address healthy aging, the point is we have to address structural determinants as well, such as poverty or childhood hunger. So those who do perinatal care, early childhood care, that matters for lifelong brain health. But midlife factors matter as well, like cardiovascular risks and protective factors. Bolstering sense of safety, providing sufficient education can confer lifelong benefits. Then the context matters. So we need to think about things like poverty, because in this case, it was a stronger predictor in cognitive aging than even a new cancer diagnosis. But again, this is at baseline. So as people progress through treatment, we'll reassess cognition at the end to see who indeed maintained their cognitive health throughout treatment. I'm going to talk just a little bit about structural brain aging. So in this study in collaboration with the Department of Radiology, Dr. Sheila Panda and Samuel Nguku, we have enrolled people and given them T1 MRI scans. So we have MRI scans now from over 500 people. What we're looking at next will be baseline MRI findings. Again, ages 35 to 81. And each scan we've processed with FreeSurfer, which segments gray and white matter structures and calculates the volume, the thickness, and the surface area of different brain regions so that we can look at changes in structural brains with the structural brain imaging with age. What we found is that the cortex of the brain, so the gray matter mantle that winds its way around the outside of the brain, does thin with age. And that thinning occurs at a peak rate of 6 to 8% per decade. It's strongest in areas like the superior frontal lobe and the middle temporal lobe and the medial parietal, precuneus, inferior parietal regions. And that is very much on par with what has been found in global imaging samples. The rate of change is very similar. When we look at volume changes, we also see similar volume metrics as in high-income countries, where the ventricular volume increases with age and subcortical gray matter volumes like the thalamus, the hippocampus decrease with age. And that rate of change per decade can range anywhere from 2 to 4 to even 14% for overall ventricular volume. And volume declines in a somewhat linear fashion with age, with the exception of the amygdala, which showed a nonlinear effect. We're interested in looking at the impact of poverty on structural brain aging. So we modeled the people who had multidimensional poverty, which is the pink line here, the red line, and those who did not have multidimensional poverty is the blue line. And we predicted there'd be an interaction. What we originally thought would there would be more accelerated aging, more accelerated structural brain aging in those who'd had exposure to poverty. But what we found was actually the opposite. There was indeed a significant interaction, but those who had exposure to poverty had more stable amygdala volumes and white matter volumes. So at first we thought, how could this be? But the more we thought about it, the more we realized that these are people up over here on the right side. So these are older people who've lived beyond life expectancy. So these are our survivors, and we have to think about this in aging research, what's called survivor bias. Those who survive showed stronger brain aging, right? So the way to think about that is those who've had exposures to stressors in their life may actually show more resiliency in their structure of their brain. So to put it in the words of Nietzsche, what doesn't kill you makes you stronger. In this case, those people who live beyond life expectancy may be teaching us something about how to withstand the stressors of life with minimal brain impacts. We looked at intrinsic capacity with the World Health Organization scale. That's a multimodal scale of cognition, sensory, vitality, psychological, and mobility, and found that those who had higher intrinsic capacity had better gray matter volumes, stronger white matter volumes. And interesting, from the radiology team, they went and scored each of the MRIs with a Vesica score, which is a measure of white matter burden, and found that that score, which could be calculated clinically without even the full morphometric pipeline, that score was associated with reduced intrinsic capacity. So that's an important clinical implication of our findings, that should someone show a high Vesica score as they approach, let's say, an intervention, a surgery or cancer and aging, should the treatment team be aware of reduced intrinsic capacity or ability to sustain the impact of that procedure on brain aging? Another way of thinking about that is, would they be at higher risk for delirium or adverse outcomes with a procedure if they have reduced white matter integrity. So I'll turn it over now to my colleague Alaka to talk about the wearable data from this study. And I will stop sharing so he can share his own slides.
Thank you, Prof. I believe you can see my slides.
Yes.
Yes. Yeah, I'm going to talk about the wearable score and some of the metrics that we are trying to gather, that we've gathered for the past 12 months, that we believe are important towards determining brain aging. And for the wearable score, we have three kinds of data that we have gathered over time. So the first kind of data is the weekly ecological momentary assessments, which is a questionnaire that has a set of 10 questions that asks the participants that we have how they felt for the past 7 days or for the past week. And it is categorized into four main categories. That's the mental wellness that looks at the mood, stress, focus, and how fatigued they felt. And they get to answer that through their mobile phones. The second category is the behavior and lifestyle, which looks at physical activity, productivity, and social interaction. Then we ask them about their sleep quality and restfulness. And lastly, we ask them about the context. So that forms the EMA. And I think the important thing to note here is that we ask the set of questions based on how they felt for the past 7 days. That is a very important piece of information because I'll be showing some of the results that we've tried to correlate to the EMA. The second kind of data that we look at is a spatial span test, which is a computerized test that looks at visual working memory and attention, just to try and see if they are able to remain, or rather show consistency in their spatial span memory. How this works, we present them with a game that has a set of flowers, and the flowers light up in a given pattern or in a given sequence, and the participant is expected to recall the sequence of the flowers. And depending on how well they play the game, it gets complex or sometimes simpler. And we are able to retrieve scores from this game and try to relate it with other data from the other subsets of data that I'll talk about. The third and also a very much interesting kind of data that we've gathered is the Fitbit or wearable data. We gave a number of our participant Fitbits that look like the one that I'm wearing. This is Inspire 3 model kind of a Fitbit, and from this we collect not weekly but daily data. And some of the important metrics that we collect from the Fitbit is sleep data that looks at, for example, sleep duration, or sleep efficiency, or the different kinds of sleep latency, that is the sleep stages that the participants go through. We also look at the breathing rate of the participants, the number of steps they have made on average every given day, which also translates into the distance they have covered. We look at things like resting heart rate. And one of the most important metrics that we get also from the Fitbit is the heart rate variability, which is basically when you listen to the heartbeats of the participants using the Fitbit, you are able to tell the interval or the duration between the subsequent heartbeats, and then try to see how that varies from in between those durations, or rather interbeat durations. This is a very important metric because it helps us to gauge some of the stressors that affect or rather it helps us to gauge how well the participants bounce back from the stress that they face on a daily basis. And this, we believe, is an important marker for trying to determine resiliency among the different participants. So these three kinds of data is what gives us the integrated insights. That is the weekly EMA, that is ecological momentary assessments, that is from the 10-item questionnaire, the spatial span test, which assesses the spatial memory of the participants on a weekly basis as well. And then we have the Fitbit data that gets the daily data. Some interesting fun facts that we've gotten from the Fitbits is when we look at all the about 195 participants that we issued the Fitbits with, the total steps that they've taken, if we were to sum it up across all participants, is about 431 or 432 million if you round it off steps. And if you look at that in terms of the distance, it's equivalent to running 7,000 full marathons, or taking about 7.4 trips around the earth. And I think that's quite an important point when you look at wellness as a communal thing. It's encouraging to note that the population that we have, or even that we studied, is a representation of the population that we have in Kenya as an active, or physically active population. You can also see that through the total calories burned and also the average steps per day. That is just some fun fact. But more important is the adherence that we realized through our participants. When you look at the wearability of the Fitbits that we gave them during the day, you can see over the past 1 year has been quite satisfactory, very much continuous for a majority of the participant. And I think that is encouraging to us, because it shows us that the kind of data we are collecting is sort of wholesome, with a few missing data here and there. So that has led us to quite some interesting discoveries for the data. A key point to note again is for the population that we studied, the wearability for the Fitbits over the night was comparatively lower for, if you look at the daytime versus the nighttime. So the nighttime was comparatively lower. I think it's a peculiar habit of the population that we have not to wear the devices when they go to sleep, but still compounded over the year, we can see that a good number of them still continuously were able to wear them during the night, and we still managed to salvage quite a lot of nighttime data that has led us to get some interesting insights that I'll soon be sharing. So now I will just look at, or rather talk about some of the interesting discoveries, or some of the attempts we are trying to do towards assessing resiliency or brain aging from the wearable score. The important thing to note is, before even we start applying these metrics towards predicting resiliency and all that, it's important to validate whether the data that we have behaves in a manner likely to suggest that it is in tandem with the pre-existing studies in the same area. So, for example, one of such assessments, or one of such analyses that we have done, is to do a subjective versus objective analysis of the Fitbit versus EMA data that I talked about. And like I said, we asked the participant, for example, how physically active have you been for the past 7 days? So that we look at that as subjective data, because it's based on how they feel that they've been physically active, and they'll record that on their mobile phones, and we capture that data. But so as to compare it with the data that we have from our Fitbit, we lag it, 7 days behind. So as to see, okay, the Fitbit is, 7 days ago showing us this is the number of steps that they took. Is how does that relate to, what they are saying from the questionnaire, the EMA questionnaire? And already from that, we are able to see there's quite a positive correlation between the steps that they take and the mean physical activity across the participants. And you can see for those who took few steps, they recorded low physical activity, when they were asked on the questionnaire. And that, I think, is quite encouraging, because it helps us to validate the data that we have so far. And now when you look at the sleep data, because like I said, we were able to gather quite sufficient sleep data. In this case, we analyzed about 90 out of the 195, about half of the population, and we try to see the distribution of their sleep pattern. And there are many other metrics that perhaps we shall address in future talks. But for now, we are able to see that the study population registered quite satisfactory average sleep duration of about 6.9 hours per night, which is quite good. But then when you look at this again, there are some quite extreme cases both on the low and the higher end. We have those who a good number who sleep less than 8 hours, and then those who are slightly above. But then that is, I believe, characteristic of any given population. I talked about a heart rate variability, which is the inter-heartbeat variation, on average for each participant, and we look at that on a daily basis. This is a very, very, very important metric when we try to see how resilient the participant is with regards to bouncing back in terms of stress. So one of the items we ask about in the weekly questionnaires is how stressed the participants have felt. And so we try to correlate that with the heart rate variability that we get from the Fitbits. And as much as this, we are still trying to discover this data, in detail, and also we are trying to, understand our population. Already, we are getting quite encouraging analysis where the correlation between the HRV and the stress is, as expected, is on the negative, as you can see from the R value there. And a good number, almost all of the participants, when you look at this plot on the right, when you look at the participant slope, which is the slope, rather the HRV versus stress slope, is rather, for a good number of them, it falls below 0, which is quite impressive. It shows that indeed the data that we are getting from the Fitbits is valid. And also important to note is that usually the HRV metrics from the Fitbit is computed, or rather is computed based on the sleep data. So where the sleep data is not sufficient, we will not get HRV data. But because already I've said that we were able to get sufficient sleep data, I think it is mirrored in these results that our data is quite good and quite encouraging, also given that it shows a negative correlation between HRV and stress. So now, why are we saying that the correlation is expected to be negative? If the beats between, rather the heartbeat, the duration between the heartbeats is longer, it means that you are relaxed. So you have stress because it will be like that, and then as some duration passes, then the next heartbeat. So that shows that there's some level of relaxation in the participant. But when the duration is quite short and it is rapid, that is associated with some level of distress or some level of stress. So given that scenario, it is expected that the correlation will be negative. That is to say, when the HRV is high, it means that the stress is low. And vice versa, that when the HRV is low, the interbeat duration is low, then the stress should be high. Just that in our data looks good, and we try also to correlate the HRV across our studies. Like Professor Blackmore said, our participants range from 35 and above all the way to about 81 years of age. And as you can see again, there's the older you get, the lower your HRV. And I think also that is very much in line with some studies that have been done out there. For example, the study that I'm highlighting here by Nataraj and others that was done in 2020. So there are a number of other analysis that we have done, but I think because of time, we shall be sharing them in future talks. But so far, that is it from my end. I think I'll hand it back over to Professor Blackman.
If you could advance the next slide, or I could open mine up again. That's okay. Here we go. And I'll just advance a little bit more to share some conclusory remarks. Because the data that Alaka has shown is, really an key part of the puzzle. As if you're clinicians in the room, as you follow your patients over time, you know that people have ebbs and flows in their health. Sometimes we go through periods where we feel, not as much vitality, but we like to think after injury or surgery that we can reverse. So curves are representative of what we believe we'll be able to out of the Fitbit data. So the latent levels, some will have declined, but they'll be able to recover. So in and some will have decline and may not be able to recover. And that's what we want to prevent as clinicians. We always want to help people bounce back and get their lives back after an illness, and prevent a decline into frailty or dementia. So we will be looking at this data to model those latent profiles and identify baseline differences that could predict who falls into each of these profiles and potentially provide sufficient support for people who are at higher risk, who have less cognitive resiliency, so that as they proceed through treatment, we can prevent disability or quality of life. So to summarize, this is a review we published in Nature Medicine that highlights not just the risk factors, but the resiliency factors that we can provide as a society to help people maintain their health, providing safety, security, financial and physical security and safety, healthy relationships and connections, a strong sense of identity, and that can be cultural, religious, things that people turn to in time of distress to help them bounce back. So by looking at risk and resiliency factors, we can more appropriately predict or support people in dealing with the stressors of life. So we've introduced the term the protectome to account for all of the factors, the safety, the green space, social connections, nutrition, to provide resiliency throughout the lifespan. In contrast with at-risk aging, we believe that there may be things like vascular risk factors, midlife risk factors. It may be harder to predict because it's so individualized. We do a better job at predicting resiliency because perhaps by providing a set of conditions to help most people flourish, we can have a larger impact on brain aging at the population level. That early adversity is not fate. By protecting these factors and providing a buffer against life stressors, we can help people age better, which is what we're trying to do with the Africa Fingers trial. Over the next few months, we'll be analyzing the 12-month data to see what factors actually did predict change in cognition across that time period, modeling their latent profiles and identifying multi-omic biomarkers of brain and body aging. Thank you to our funders and to the BRK babies that have been born over the past year. We do this work so that their generation will live longer and thrive. It's important that we turn these insights into better care to help each generation become more robust, more resilient than the last. So again, this is a team effort. We have a very large team. I'd like to thank Catherine as our project manager, who has been really the reason all of this has happened in such a short time frame. Our clinical co-investigative team have been essential. We're dealing with people who have lots of challenges, and I'd like to thank Dr. Mbugua for seeing some of our patients who've had adverse findings, unexpected findings on MRI. So people go out of their way to really support our participants and patients, and we're grateful to everyone, especially the research grants and research office and finance, and Rosemary and Josephine in legal. There have been so much support from the larger AKU community to make this work possible. So let me close and open up for questions.
Thank you so much, Drs. Blackmon, Dr. Laka. we will spend the next 10 minutes answering questions. We will start with the questions on the chat. Afterwards, we will give room for, I see Dr. Saleh's hand is up. He is a co-principal investigator in this study, and I know as the event picks up, he might be answering some of the questions that you have highlighted. So we'll start with the questions on the chat. If you do have more questions, you're welcome to raise up your hand. So our first question, let me see. Okay. So our first question, please explain how reduced physical activity is a predictor for resilient aging. You want to take this, Dr. Blackman?
Yes, it's such a great question. It's one of the surprise findings. We suspect that it has more to do with, physical activity not being the people going to the gym, but because they're laborers and some of the participants may be pushing a cart, walking, more than 30,000 steps a day. And that brings it more from this category of physical activity that we see in the global north as being so important, going to the gym, but these are people living their lives. And so physical activity isn't always protective in that context. It maybe it's a proxy for a lot more stress or that's going on as they try to make ends meet. But Catherine, we've talked about that finding a lot as a team. Did you want to add your thoughts on that? Because it's been a point of active discussion amongst our group of why this sample and this data may be different than what you see in the global north.
Thank you, Karen. So like you have explained, how we conceptualize physical activity in our context was really different, because we realized that people who seemed to do more physical activity as a result of the hassles of life, they didn't perform any better. So it gives us room then to reconceptualize what does physical activity mean to us in our context, and how to do it effectively to determine resilience. Yeah, thank you. So the next question, given the number of risk factors explored and the fairly modest number of participants recruited, did the study have sufficient power to conclude that lower levels of education and HIV were associated with less resilience?
So I think that's a fair point. I mean, we had 246 people in the sample, but what we did when we did logistic regression into these smaller groups does reduce power. So I looked at a continuous linear regression as well, and the findings were very robust. So the effect sizes were very strong for early life hunger. I see there's a question, how did we assess that? That was by simply asking people, when you were a child, did you get enough food to eat? Were there times when you didn't have enough food to eat? So it's retrospective, which of course may have error, but it's the best we can do at a single time point in aging research. And it turned out that single question has high yield. So I would strongly recommend for others studying aging that you ask that question, because it's an important thing for your risk modeling. I want to make sure we also get to Professor Mansour Saleh's question.
Yeah, he's actually next. Right.
Okay, he's next. Sorry. Okay. Yes, but of course we works our hardest to get a large sample. It's never large enough, but the effects are so strong. We saw it even early in our preliminary analyses. We already saw that effect coming out. So I don't know that more participants would change much. The poverty effects were so strong. There is a question about why, probably reduced healthcare access. When it comes to sanitation, there are effects of exposures on cognition. So those are probably some of the reasons. Levi Muyela, who's here, did an analysis of each of the individual poverty predictors and found that simply indoor sanitation was a major factor, not just water and food security. So those are things we'll be breaking apart in future analyses. Professor Mansour, please. Sorry to yeah.
Hi, Karen, Bernard. I mean, fascinating stuff. So I have a couple of comments and then a question. First of all, it's incredible that we have a Brain and Mind Institute here in East Africa at AKU. I don't see anything like this in Africa for that matter. And the tentacles of BMI go all the way to northern Pakistan, to Dartmoor, to Nairobi, and now to East Africa. And I see that Zul has lost all his hair, whatever he left behind when he came from Ottawa. So congratulations to him, to the team, for doing this kind of stuff that really has never been done before. Now, many of us may criticize to say sample size is small, give us this small, give that. We've never done this before. So this is the beginning of many things to happen. And I would really look at it as a action in motion. You have to have some baseline. This is the baseline. While we may be critical about many things, let's appreciate the fact that this was not possible before in Africa, and now it has been possible with this kind of network of people working on one cause. My question, though, is I saw the predictive factors. And Rodney has also asked the question about childhood poverty, childhood hunger, poverty. Are those predictive factors that you found here in Africa different than in the West? Or have we found similar factors in places like Mississippi or in Gaza? Is this a new baseline to suggest to the world to say that we should be paying importance to our children when we feed them at the beginning? So, first, have we seen this in the West? Are they the same predictive factors or are they different? And what are the policy implications of what you've shown? Thank you.
Exactly. There are policy implications. I think it's fair to be cautious with our results because they're cross-sectional. When we have the longitudinal data, as we're almost finished collecting, we will be able to make stronger statements to see whether indeed those who were cognitively resilient at baseline sustained more stressors over the course of the year without progressing to frailty or decline, cognitive decline. So that longitudinal data will give us some strength and oomph to our policy statements. If I had to make, I guess, a statement of which structural levers we should address, paying for secondary school, giving kids lifelong brain health through promoting education, supporting education, helping build brain capital for society by giving them sufficient early nutrition and education. We've known this for years. We've known this for a long time. This data further supports that it's not just important for, healthy kids, it's important for lifelong brain health. But again, we can make that point stronger when we have that longitudinal data. I think Professor Opio's point here, when we do the logistic modeling, again, we have smaller groups, so our odds ratios are the confidence intervals are wider. So when I do continuous linear modeling of cognitive outcomes, that actually allows for robust capture of these predictive factors as well. And when Dr. Opio IC asks, could we account for relatively small? So they are strong effect sizes, but in small samples of 250 people. I think at this point, the data that we get from the longitudinal will convince any skeptic that these risk factors and resiliency factors are robust. So yes, that's a good point.
Maybe just to help you there, thank you, Tim. You're doing a very good job. You could try fast logistic regression for small numbers. That will strengthen your publications and etc. And in your models, kindly, the biostatisticians are there. Usually, if you're going to publish this stuff, they will ask you for the performance of your model. So it's nice to have them in loop so that if you get somebody who is critiquing your work, yes, you say you have these small sizes and so forth, but it's robust enough to make an initial decision so that this can also be sent out while you're waiting for your longitudinal data. Thank you.
Yes, well, just to share the overall performance of our resiliency model was a discriminative accuracy of 0.9. So that sensitivity specificity was sufficient for our funders to be very happy and highlight this work to the other teams, that out of all the teams in the Dynamic Resilience Program, we were the first to build a model to predict resiliency with that high level of discriminative accuracy. So although I want to be modest with cross-sectional results, I also want to brag about our team's work and the Global Dynamic Resilience Program and how we've actually done a great job, even with behavioral or scales and questionnaires, to predict cognitive resiliency at that high accuracy.
And maybe just to help you again, so we're moving from just single references. I'll put it to you and say, what if your reference is, you don't have a standard reference or a gold standard? How would you analyze this data? I'm just putting it to you just to enrich your work.
Yes, I think that that's fair, but we're defining a gold standard for the region.
So maybe you may consider latent class analysis, okay, because you may pick up groups that may be beneficial. So you can do your initial logistic, then kindly just think about having somebody do latent class. So you may be able to pick up certain groups of individuals that may be.
Wonderful suggestion. That's going to be very rich. Thank you.
All right, thank you, everyone. A few questions that were on the chat. Thank you, Dr. Bosire. You've answered to some of the questions, and we have come to the tail end of this presentation. Thank you, Drs. Blackmon. Thank you, Dr. Laka. And I want to acknowledge the presence of our director at the Brain and Mind Institute, Dr. Zol Merale. Thank you for your presence. We are honored. You may learn more about our studies through our website, the Brain and Mind Institute. You can write directly if you have questions and contributions, because I see there's still a lot of contributions that are within the group. You may write directly to Drs. Karen Blackmon and Alaka. I have put their addresses on the chat. You can write directly to them on email. If you wish to collaborate with them, you can just reach out to them, including Dr. Zul Merali. His address is zul.merali@aku.edu. Thank you, everyone, and thank you to the research team for giving us the opportunity to make this presentation. I wish everyone a good day, a good night. Thank you so much.